All right, let's continue section 4.1. The next one, number 5, says identify the x-coordinates of the points where the derivative is 0. Well, we already looked at that. The derivative is 0 at this point at C, also at D, and at F. So those are 3 x values, x equals C, D, and F. All right. Number 6 says identify the x-coordinates of the point where the derivative does not exist, and I already wrote that on here. That was B and at G. So I wrote that down. So I wrote that the derivative f prime of x does not exist at x is equal to b and x is equal to g. Now, number 7. Number 7. It says identify the coordinates of the point where f has a local maximum. And then 8 says identify the x-coordinates of the point where the function has a local minimum. So notice where the function does not exist. Think of that as just like a mountain range. This is a maximum, there's a minimum, this is a maximum, and this is a minimum. And we call these local maximums because just in the vicinity, like locally, that's a high point. It may not be the highest point because this may be higher. It's not the highest point of the range, but it is a high point. So we say that this has a local maximum at B, a local minimum at D, as in dog, a local maximum at F, and a local minimum at G. And notice that that is where the derivative is either 0 or does not exist, and that's an important thing to notice. So I wrote this down, that we have local max at x equal b, f, local min at d and g. Now, 7 and 8 we're done with. Let's take a look at what's coming. Here is kind of a summary of what's coming. We're going to be using the first derivative to analyze a function. So the first derivative, the function f of x is increasing when f prime of x is greater than 0 and decreasing when f prime of x is less than 0. That's kind of a formal statement of what we've been doing. The critical numbers, these are the values of x for which f prime of x is 0 or undefined. So those are going to give us local extrema, or local maximums and minimums. Local extrema, which is maxima, that's the plural of maximum in the math